Hi everyone, today's lesson is 7.1, Multiplying Monomials. So we need to start by saying, okay, what is a monomial? So a monomial is a number, variable, or a product of a number and one or more variables. Okay, and that is going to be really important throughout this entire chapter. Okay, so a monomial, it's either a single number by itself, a variable by itself, like x, or the product of a number and one or more variables. So that would be an example like 2x, 2xy, anything like that. Okay, we also have something that's called a constant. It's a specific type of monomial. So we're going to say monomials. That are real numbers. All right, so they have no variables attached. So it is just a number all by itself. So our first example, this is what we're going to do. We're going to try to classify each of them, so determine whether each expression is a monomial, and then we have to explain our reasoning. So for A, it says 17 minus S. Well, if we look back at the definition of a monomial, it's a number, variable, or product. So don't forget, product means multiplication. Right, so is 17 minus S, is that multiplying? Nope, that is subtracting, so this is not a monomial, so no. And for the reason, I'm going to put just it involves subtraction. Okay, because it is not allowed to involve subtraction. All right, the second one, part B, it says 8f squared g. So this has numbers and letters all being multiplied together, so we are going to say, yes, it fits that definition. And our reason, it's the product of numbers and variables. All right, now letter C, the third one, 3/4. So 3/4 it's showing division there, but a monomial says it can only have multiplication. But what we need to think about in this case is 3/4, even though it's showing division, it's just a number. So this is a monomial because it's just a number, and it's actually, since it's just a number by itself, it's a constant term. And you guys should be familiar with constants because we did this way back in the beginning when we learned about what constants were, what variables were, and what like algebraic expressions were. All right, D, the last one, it says 5 divided by t. So this one looks very similar to C. The only difference is there's a variable in the denominator. So what we need to think about, the last one, 3/4, it was a monomial because it was just a number. 3/4 is 0.75 in decimal form. Can I write 5 divided by t in decimal form so that it's just a number? And the answer to that is no. So we are not allowed to divide by a variable. So we're going to put division of a variable. Okay, because that we cannot do. All right, so take a moment, try the your turns, and then, so pause the video, try it, and then come back and see how you did. So for the your turn, it says, which expression is a monomial? So D, I'm going to cross off right away because I see, oh my, I don't know where that went. Because we see if I can undo it. Okay. Because, hang on, my thing's being weird. Okay. because we see that C and D are being divided by itself. Oh, I give up on it. All right, for C, that also has division. Oh my goodness. That also has division of variables, so we're not going to do that either. Hang on, I'm trying to fix this a little bit. Okay, maybe it'll work now. B, we see subtraction, so that doesn't work. A is the only one that is just a variable by itself. It does have an exponent, but if you think about that, exponents just mean 2, 3, 4, 5, that I have 5 x's being multiplied together. If we go back up a monomial, product of a number or one or more variables. So my number would be 1, and then it's just being multiplied by a bunch of x's. So that's why we are allowed to have exponents. All right, and getting into, excuse me, that whole notion of exponents. That is what the majority, actually, that is what Chapter 7 is about. We are going to learn a whole bunch of rules for exponents. Now, because we are low on time, we have this week and next week, we are going to fit all of them in. So, let's go ahead and get started. Now, each of them individually, they're easy, but the biggest complaint I get about students, or from students with these, is that it's hard at the end when all of them are mixed together. So it's going to be really important that you do your practice work each day. All right, so first one, it says product of powers. Okay, so it says to multiply two powers that have the same base, we add the exponents. So here's our example. If I'm multiplying a to the 4th times a to the 12th, we do a to the 4 plus 12, and if we add them, we get a to the 16th power. So I'm going to pick smaller numbers to show you this. So if I do a squared times a cubed, what that means is that I have a squared, a times a cubed, 1, 2, 3. That's saying, okay, how many a's do we have now? 1, 2, 3, 4, 5. So we get a to the 5th. So if I follow the rule, that would be a to the 2 plus 3, and 2 plus 3 is 5. So that's just a quick explanation of that rule. So when you multiply like bases, you add the exponents. The key word there is like bases. Notice how both of them had a's. If I had a squared times b to the 5th, I could not combine that. This would be my simplified answer. All right, so let's take a look at example 2. I have r to the 4th times negative 12 r to the 7th. So I like to multiply my numbers first. So the number in front of, or the coefficient in front of the r to the 4th is just a 1. So I have 1 times negative 12. So I get negative 12. And then I'm going to write r to the 4th times r to the 7th. Since they are like bases, I'm going to add the exponents, and then 7 plus 4 is r to the 11th power. So negative 12 r to the 11th is the answer. All right, let's take a look at B. Same thing, but they gave us several different variables. So I like to put everything together. So I'm going to put my constant terms together, or my coefficients. So 6 times 5. Then I have c times c to the 5th. And then I have d to the 5th times d squared. So notice I put the terms that were alike together. So 6 times 5 is 30. C, don't forget that 1 there, to the 1 plus 5, times d to the 5 times 2, plus 2. So we get 30, c to the 6th, d to the 7th. Right, so take a moment, try the your turn. There are 2 of them, and then come back and watch the video. All right, so for these your turns, 5 times 4, x squared times x cubed, So we get 20x to the 3 plus 2. So we get 20x to the 5th for the first one. Now for the second one, a lot of you are going to want to try to distribute this. There is only one term under there, so there's no distributing. It's just multiplying. So I get 3 times negative 2, x times x squared, and y squared times y cubed. So we get negative 6 x cubed, because remember 2 plus 1 is 3. 3 plus 2 is 5. So negative 6 x cubed y to the 5th. So that's our first rule of exponents. We multiply like bases, we add the exponents. The second rule is called power of a power. So it's when I'm going to have an exponent raised to another exponent. So it says to find the power of a power, you multiply the exponents. And again, they have an example here, but I'm going to use smaller ones to show you. So if we have, we'll do a squared cubed again. So the first thing I need to look at is this exponent. It says I have 3 a squareds. So a squared times a squared times a squared. So I had 3 of them. And now each a squared means I have 2 a's. So a times a times a times a times a times a. So how many total a's do we have? Well, 1, 2, 3, 4, 5, 6. So here we get a to the 6th. So that shows if I were to take the shortcut, I would take a to 2 times 3, because a power to a power we multiply, and 2 times 3 is 6. So this rule says if we have a power to a power, we multiply them. I don't care how many you have. You could have 20 exponents to another exponent to another exponent to another exponent. You multiply all of them together. So in this case, I'm going to start on the inside. It doesn't matter. I could start on the outside or the inside. So I'm going to do 2 to the 3 times 3. And then leave that squared guy out there for a second. So 3 times 3 is 9. So I have 2 to the 9th squared. So now I need to take 9 times 2. So 9 times 2. Whoops. And we get 2 to the 18th. And that's your answer. Now, you could, if you wanted to, type this in your calculator. And if you need an exponent other than squared, you need to find the button that looks like that and then type in 18. So a lot of you, even if you just have a basic scientific calculator, just look for that little caret button. I don't have one in front of me, but sometimes it's like X to the Y button. That's what the button looks like. You push that. So just play around with it. If you use the Calculate 84 app on your iPad, you will do this bottom one here. So if we do 2 to the 18th power, it's a big number. It's 262,144. Okay? So take a moment, try the your turn, and then come back. All right, so hopefully you got 4 to the 12th. All right, I think we have one more rule today. And then we have a couple more examples. Today is sort of a long notes day. So we have, in recap, we have if you multiply like bases, you add. If you have a power to a power, you multiply. And our last one sort of reminds me of distributive property for exponents. It says if we have a power of a product. So to find the power of a product, find the power of each factor and multiply. So here's our example. I have negative 2xy. All of it is being cubed because that 3 is outside the parentheses. So this is why I said it's sort of like distributive property. Notice they took negative 2 cubed, x cubed, y cubed. So that exponent of 3 got distributed to each term inside of there, or each factor, I should say, inside of there. And then they simplified the negative 2 cubed to negative 8. So let's try this one. It says find the volume of a cube with a side length of 5x, y, z. So several ways you could do this, but following this, the volume of a square is s cubed. So s represents the side, so it's side length cubed. Well, if its side length is 5x, y, z, then I just have to cube that. So that means 5 cubed, x cubed, y cubed, z cubed. And the only thing I need to do to simplify this is I cannot leave a number raised to an exponent because that's not simplified. So I need to take 5 times 5, which is 125 times, 5 times 5 is 25 times another 5 is 125. And then we just leave it x cubed, y cubed, z cubed. Okay, so take a moment, try the your turn, and then come back and double check it. All right, so I'm going to explain this because surface area is a little bit different. So surface area is the area of every face of this. So since this is a cube, there are 6 surfaces, or 6 faces is what they're called. So we need to find the area of one and then multiply that by 6. So the surface area is, since it's a square, length times width, and then we have to multiply that by 6. So I'm going to do 2pq times 2pq, and then 6. I could have done 2pq squared. That's actually technically what they wanted you to do here, but it's just as easy to do it this way. So 2 times 2 is 4. P times p is p squared. Q times q is q squared. And then I have all of that times 6. So 4 times 6, so we get 24. P squared, q squared. And that would be units squared, whatever those units may be. All right, so we have one more example. This key concept box is just, it's going to be helpful for you. It explains what you need to do to simplify monomials and how to write equivalent expressions. All right, so these last 2 examples are combining everything we've done today in the notes, and it's going to be a lot. So the first thing I like to do is simplify each piece. So I'm going to ignore that part right there. I'm going to simplify the first part. So I have 2 exponents outside. So those exponents, I need to multiply them together, which makes it a 4. So I'm going to have 8g cubed h to the 4th, all to the 4th power. So now that means I have to distribute that 4th power to everything. So 8 to the 4th, q cubed to the 4th, and h to the 4th to the 4th. So 8 to the 4th power is 4,096. Q cubed to the 4th, I'm multiplying, so that means I get q to the 12th and h to the 16th. All right, so now I'm going to block out this first one and simplify my second one. So this only has 1 exponent outside, so I'm going to put my multiplication there. So that means I need to distribute that exponent of 4 to everything. So I get 2 to the 4th, g to the 4th, h to the 5th, to the 4th. So now simplify that. I'm going to skip down here. So 2 to the 4th is 16. I get g to the 4th, and then h to the 20th power. So now that I'm here, I need to put everything that is alike together. So I get 4,096 times 16, q to the 12th, times, that is a g, times, I don't have another q, so g to the 4th, times h to the 16th, times h to the 20th. And now multiply things that are alike together. And I am sorry, that is a G the whole entire time. So this is a G. That is a G, that is a G, that is a G. All right, so now I do have two G's. So I'm going to go up here because I'm running out of room. So if I multiply 4,096 times 16, we get 65,536. I have G to the 12th times G to the 4th. I'm multiplying like bases, so I add the exponents. So 12 plus 4 is 16, so that becomes G to the 16th. And then finally, I have H to the 16th times H to the 20th. Again, we're multiplying like bases, so add the exponents, so that's H to the 36th power. So after all that work, we get that big answer. All right, so this is the last your turn. Pause the video, take a moment, try it, and then come back and check your answer. All right, so there's your final answer. You should end up getting 1,728, C to the 27th, D to the 24th.